Hi there, today's session is about momentum. This is a physical property denoted by the letter P. I have no idea what's the letter P, but it's calculated by mass times velocity. And remember, velocity is a vector, so that means momentum is also a vector. So you can calculate the momentum of an object. Let's start off with some examples for you. What is the momentum of a 1,000 kilogram car traveling 60 kilometers per second due north? And what is the momentum of a 300 gram snooker ball traveling right at 4 meters per second? The momentum is obviously 600 kilograms per meter per second, meters per second I should say, north, and 1.2 kilogram meters per second to the right. So that's how you can calculate momentum. Now, change in momentum. The momentum of an object will change due to the interaction or normally a collision with another object. Okay. So therefore we can also measure the change in momentum. And that's just final momentum minus initial momentum tells us the change in momentum. So, here's a problem. A football of a mass 0.5 kilograms is stationary on the penalty spot. It is kicked away to the left with a velocity of 30 meters per second. What is the change in momentum? So hopefully you've spotted here that the initial momentum is actually going to be 0 because it is stationary. The final momentum is going to be 0.5 times 30, which gives me 15 kilogram meters per second, and therefore the change in momentum is 15 kilogram meters per second. Now, one of the key things about momentum is it's normally conserved, okay? So that means that if the net external force on a system is 0, the velocity of the center of mass in the system is constant, and the total momentum of the system is conserved, that is, it remains constant. So normally if we have an enclosed system of some sort, so that could be two objects not being affected by any outside forces, but they could interact, then the initial momentum is going to be equal to the final momentum. This actually explains recoil. So we think about the initial momentum and the final momentum. What we have, if we have a gun, the initial momentum is 0 because neither the gun or the bullet are moving. However, when the bullet is fired, it has a momentum in one direction, so that's the mass of the bullet multiplied by the velocity, and therefore for the total momentum of the system to be 0, in the opposite direction we must have the mass of the gun moving away at a different velocity. So their total momentum is going to be equal to 0 at the end. So that explains why recoil takes place. So here's a conservation of momentum question. A bullet of mass 50 grams is fired from a gun of mass 2 kilograms at a speed of 450 meters per second. Calculate the speed of recoil of the gun. The total momentum before and after is 0, as there's no velocity to start with. So therefore the momentum of the bullet is going to be equal to the momentum of the gun, but in the opposite direction. If we rearrange this for the velocity of the gun and then plug in our values, we work out that the momentum of the gun is going to be 11.25 meters, and the velocity